We are now in the first lesson, lesson 1.1, and it's about discrete and continuous random variables. And our memory verse is found in Numbers 13, 1 and 2. It says, "The Lord now said to Moses, send men to explore the land of Canaan, the land that I'm giving to Israel. Send one leader from each of the 12 ancestral tribes." At the end of this lesson, you'll be able to illustrate a random variable, whether discrete and continuous, and second, distinguish between a discrete and a continuous random variable. Now, for example, imagine you'll be interviewing two people and you will write their answers on the space being provided. So, for example, how old are you? Let us try to imagine that we're answering for somebody. Okay, help me answer in the chat box. It might be different people, but let me check on that. Wait first. Okay, ready? Help me in answering. The first question, how old are you? Answers. Oh, I've seen 18 and 17. Next question, how many people are there in your family? 4, I've seen 5. Next, what is your favorite number? What's your favorite number? I've seen 12. I've seen 2. Next, number 4. How many students are there in your class? How many students are there in your class? I've seen 16. I've seen 17. Next, what is your mass? What is your mass? What is your mass? Oh, 37.5. Wow. 57.2. Next, how tall are you? How tall are you? I've seen 5'6", 5'2". Okay, thank you so much for participating. Now, let me check first, because you see, you only know you're 18 years old and 17, right? But in reality, you're not exactly 18 or 17. So of your 18 and 1/2, let me check. Some of you are 17 and 3/4. You're exactly 18 or 17. Now, what have we noticed with our answers? You check. How do you describe all of our answers? What have you noticed with our answers? Oh, they are different. Now let's go back to what we have learned in the previous lesson. Are our answers qualitative or quantitative? Are these qualitative or quantitative? No, very good. It is quantitative. Let me give you a hint. To remember that it's a number, there is an N, right? N for number. So quantitative. Now, how about your answers for 1? You see, our answers for 2, 3, and 4, if you notice, are whole numbers. Like how many people are there in your family? Say 4 or 5. What's your favorite number? 12 or 2? How many students are there in your class? 16 or 17? While our answers for 1, 5, and 6 has parts, if you notice, 18 and 1 half, 37.5, 5, 6, or we say 5.5, right? 5 feet, 0.5. Now, if you check, numbers 2, 3, and 4 cannot be answered with a fraction part. Like, how many students are there in your class? You say 16.5. That's not possible, right? That's why sometimes the concept of the boat is sinking. Group yourselves to 2.5, and then the other will just sit. But in reality, even if that person will sit, that's still counted as 3 because you could not count people or any population by half. So numbers 2, 3, and 4 are in whole, while 1, 5, and 6 would come with a fractional or a decimal part. Now, why did I show you this one? Let me first clear my drawings. Now, it's because it has something to do with our lesson. Numbers can be discrete or continuous. We've talked about quantitative data, all about numbers, and these numbers can be discrete or continuous. What do you mean by discrete? If you say discrete random variable, it's a numeric variable that can only take a finite number of real values. It means that the values are limited to whole number. There must be no fraction. There must be no decimal part. It must be a whole. Take example, a while ago, we asked, how many members are there in your family? 5, 6. It's a discrete data. Or how many students are there? 1, 2, 3, 4, 5. So it's a discrete data. Now, here are more examples of discrete data. Number of COVID-19 patients, like 0, 1, 2, 3, 4. Or number of enrolled students, number of schools, number of harvested apples. These are called discrete data. Now in the chat box, share with me, what other examples of discrete data do you know? Ready? Share. Very good. Number of siblings. Yes, discrete. Others. Quantity of products. Yes. It depends, right? It depends on the product. Like for example, if you're asking, pwede mo good na ay half ang uban, di ba, product? Shoe sizes. Shoe sizes, it has 7.5. So no. Number of groups. Yes. 1, 2, 3, 4, 5. Yes, it's a discrete variable. What else? You know what? It's an advantage if you keep on sharing because you didn't know what items are in the quiz. So some of these might be answered based on what you will share. Number of vaccine in the Philippines. Yes, it's discrete. Number of languages an individual can speak. Yes, it's discrete. Number of cities. Yes, discrete. Enrollment. Yes, it's discrete. So again, number of test questions you answered correctly. Yes. Number of friends. Yes. So anything that is countable, sorry, what did I do? Anything that is countable, we call it discrete data. Let's go to the last one. And this is the last page. What is a continuous random variable? A continuous random variable is still a numeric variable, but it can assume an infinite number of real values. It is any numeric variable that can take any number. There can be a fraction or a decimal part with it. It's called continuous random variable. In discrete, the answer should be a counting number. But in continuous random variable, it can be any number. My technique is I ask my class, can it have one half? If the answer is yes, it's continuous. If the answer is no, it's discrete. Example, mass. Can it have one half? Yes. So it's continuous. Number of students. Can it take a one half value? No. So it's discrete. What are some examples? Height, 60.25. Mass, age. I told you a while ago, you just say you're 18, but in reality, you're 18.5 or you're 18 and 3/4. Next, prices. 140.28, there is a decimal part, or 12.36, there is that decimal part. So we call them discrete, continuous random variables. It's sharing time. What other continuous data do you know? Speed, yes. However, actually speed can take 17.5, right? But the speedometer only would show you 80, 90, like that. Time, yes. Temperature, yes, 37.5. Length, yes, 12.5. Kilometers, yes, 1.5 kilometers. Distance, height, correct. What else? Allowance, right? Seismographs. In seismographs, yes, because we have 5.5 magnitude. Yes, it can be. I think you have understood well today's class.